Okay, welcome. Second session in the morning. Blockchain Demystified. One of these new technologies called blockchain, and we hear a lot of different arguments, different impressions. We see a lot of customers interested in that, and I hope you're part of that community. We think blockchain will change the way and will simplify the way we will do business in future. But from the first beginning said, don't fear that it will replace what you have today. So that's why let's try to demystify a little bit. What is it? How do we think of it? And how we think about it and what you can do with it. So when we're thinking of what we do today and what we did in the past, we always have business relations, business to businesses are in place since many, many years, right? That means, as an example, I want to build that on a very simple example, a real estate. Buying, selling real estate. The other entity that needs to be in that game to make business with is a bank. Of course, and the buyer, seller, whatever. But these two entities are the major ones, and I just want to build on that to the mindset, what and where do we have a challenge today in making business to business. So first of all, they do business to business, right? On one side, we might have applications which are based on a web server, and the backend based on an IMS application on IBM Z. So multiple applications running on that side, driving that real estate IT environment. On the bank, it might look totally different. We might have a CICS system on IBM Z with payments application, loan, you name it. So different applications as well. What we also know from the past is these applications, when they run, we want them to be kind of verbose, more or less verbose. That means we want to have logs to know what happened. Now, logs can be permissions, logs can be what was the behavior of the application, if it crashed, to have a look to it. So that's what we know today from this application, and we want to have that, or we have that already. Similar on the other side, each application activity is logged. Now, guess what? Each application has its own way to log information. It's a text file, you have to go through it with the timestamp and all that, but it's logged based on the activity that this application is writing to the logs, or I'm configured to do that. This is from a local perspective, application logging. Now, these applications belong to a process, to a business process. I'm doing business to business activities. I'm using different methods or different processes in my business to do that, and the applications are part of that business. And therefore, when we're looking now how the business process is monitored, that's another level where typically it's monitored in a so-called principal book of account or ledger, a local ledger where my business processes are kept, okay? Same on my banking account, or my bank with the principal book of account as well. That's another ledger. Because the bank thinks certain information are important for them, while the real estate thinks totally different information or additional information are important for them. So ledger 1 and ledger 2 are totally disjunct. Nobody sees them because the real estate typically is not showing their ledger to the bank. So therefore, we have here already a point to two-layered. You know, my application is logged, my business processes are kind of recorded, logged, whatever you call it. It's the principal book of account. Now, typically doing this business, some of these businesses are trusted in terms of I'm trusting my bank, but the bank not necessarily is a trusted environment in terms of from a national perspective, so you need something called man in the middle. So businesses like that have mans in the middle entities like central banks. Banking payments are going through a central bank. If I'm not trusting when I buy something, a product, I'm using PayPal, because if the product is not shipped, I can get my money back. So it's a man in the middle that I can use. Government regulations for enforcements. They want to have a regulation for certain activities. So these are things that we know are practiced today, and that's how it works today, the business. That's how the business works today. Where the challenge is now here is, if you're looking into a more broader network, every single entity, and we're extending now the real estate with the city administration, with a bank, the auditor, there might be an auditor that wants to know what's going on, what did you do, how is your IT set up, all that. Commercial institutions, logistic companies, and they communicate. Not everybody is communicating with everybody, but they are basically in a business-to-business relation. Everybody has its own ledger, and I try to make that through different colors, known that they're disjunct. Now think of if I'm building a product, I have different relations with my payment institutions, with my partners, with my suppliers. They have different ledgers, I have a different ledger, and I'm recording what happens in my business processes. If they change, and after a certain time I want to trace back, I have a very hard time to do that. So basically, global tracking is lacking. We have problems doing that. And think of, airline industries, car industries, all these, having many different partners and so on. It is very difficult to do that. Inefficient, expensive, and on the other hand, vulnerable. How do I trust what I find there? Or if I need to trace back, how can I trust that information that I get? So this problem was addressed by something new to get more trust in a business-to-business relation. And that's the solution using a so-called shared distributed ledger. So if the institutions or the entities making business together decide upon what are our common data that we want to share, or we want to store, we want to record, we want to log, however you call it, they build up this shared distributed ledger. Everybody has a copy, so it cannot disappear. And I know what's happening between, or what happened in the past in that business. So this is basically the solution that promises it will become simpler and it will accelerate some business processes. Okay? And if you see here that we have the same entities here with that shared distributed ledger, and I'm coming to the definition of what it is and so on. It is based, this relation here between these entities, we also call them peers, is based on a consensus. The consensus means the agreement upon which data do we want to have in common stored. How long? What is the algorithm of protecting them? How do we access? Provenance, ownership control. Who has the ownership over those data? Or who has the ownership over the actions that take place in that chain? We're coming with a new sentence, with a new word, in this business relation. Immutability. How can I make sure that nobody can change or nobody can do anything wrong to those information that we store together? And alone that all the information are stored multiple times, it's a security in itself already that they cannot disappear. And finality, I have a single source of truth. That's my shared distributed ledger. Okay? So this is the solution, and that's the solution for businesses. Now, of course, you can replace these entities with entities in the company itself, and we have global companies having centers over, in 3 or 4 different continents. That's what they can do and make that happen. But typically, it's done across different companies, across different enterprises, and I give you some examples at the end. So with that said, the most important thing that we have there is our shared ledger. This shared distributed ledger, it records all the transactions and trades across that business network. Shared between participants, we saw that. Everybody has a copy. It's permission, so participants see only what they participate in. I cannot see the transactions between other entities where I'm not participating. Makes sense. And therefore, the shared distributed ledger is the shared distributed historical database across the peers. Okay. Of course, we can decide this database can grow up and will delete every records that are older than 25 years or 10 years or whatever. So that's a consensus in that case, but the vehicle to do that is this shared ledger. So therefore, to build a trusted trade system with this shared distributed ledger, it needs a new network, a new business network type. And that's where the word or the sentence of blockchain comes in the game. So blockchain is a new business network type. And that you see immediately, it's not a transactional system that replaces something. It's recording what happens between businesses. Okay? Now, with that sentence, typically, many questions are raised because the different blockchains are available, and well, we know that it's different how Bitcoin is doing it versus Ethereum versus something else. So that's why we have to look a little bit more. So therefore, blockchain as a new type of business network is using this shared distributed ledger. So blockchain is a technology. Don't think of I can buy a blockchain. It's the technology that is underneath, and now I have to build my application on top of that technology. And that implementation of a blockchain network can be a public one, like the internet or networks that allow everybody to participate. And guess what? Bitcoin is a such implementation. It's a public blockchain implementation. Everybody can participate. There is no verification or something. You can participate and build up. So that's a public one. The private blockchains, and these are the blockchains for business, are those which have restriction who participates and have control who participates, have conditions who can participate. They need to agree to that consent and so on. And one example is Hyperledger, an implementation of blockchain technology as a private blockchain network. Okay? When we compare it now, Bitcoin versus blockchain, with Bitcoin, it is the first blockchain application. So I think if we wouldn't have Bitcoin, we would not have blockchain, because it was invented with the mindset of creating currency. But the underlying technology is flexible to do something else than just using cryptocurrency with it. When we're looking from a network perspective, it's the pioneer, it's a public network, but it's an unregulated using censorship-resistant cryptocurrency. So it is based on this unregulated cryptocurrency held in a wallet, and nobody controls it, no one controls it and sees it, decentralized, all that. The blockchain for business is for new decentralized trades. You don't see any word about cryptocurrency because it is not based on cryptocurrency. Okay? Totally different concept, not based on any cryptocurrency. So therefore, blockchain is not Bitcoin. Blockchain is a technology, Bitcoin is the implementation, one implementation of it. And if you're looking at the different characteristics with Bitcoin, the participation is with anonymity. That's where they got big, right? I'm anonymous. I can do everything. Nobody can control me. Unregulated shadow currency, and it is resource intensive. That's why we hear, these halls of compute powers that they need to produce, because the cryptocurrency is produced on the fly. So that's why there's high calculations. Blockchain for business differs in the area that it is private. It is identity over anonymity. So you have to your identity. You have to be part of it and name yourself. Selective endorsement over proof of work, and assets over cryptocurrency. Assets means I'm talking about trades, and I'm talking about a business relation versus currency. With that said, the blockchain for business is based on 4 pillars. And we saw them partially already. One of them is the consensus. All parties agree to the network and the verification of the transactions. All are based on or are using the shared ledger with the characteristics of appending only. I cannot change in the middle. And we're coming to that, how I can inhibit that. So append only, that means even if a transaction is not valid, I want to undo that transaction, it is another entry into this ledger. So I can see. It's not an undo, so I delete that, and then I'm back. I see all these operations. Okay? Shared across the business. Then privacy is very important. Appropriate visibility. You can imagine if I have 2 sellers, they have different conditions to sell the same product. It wouldn't be healthy that everybody can see what the conditions are to each other. Competition would be gone, right? So therefore, privacy, I can only see where I participate. And last but not least, conditions, when can I execute, or when is this transaction recorded to that blockchain? So that's built by the so-called chain code. There's also the term called smart contracts. And we had a little bit of a conflict with the smart contracts because the lawyers came on the plan and said, we are doing contracts. That's not a contract here. It might be an implementation of a contract, but the contract itself is not in here. That's why chain code is the better terminology. It's the condition when a such transaction in the blockchain, in the chain, can happen between peers. Might be different between the different peers, so that's why you can have one or multiple chain codes, and we will see that in a minute. Very important here is, the goal is to have a broader participation, lower cost, and increased efficiency, and blockchain is not replacing your system of record. Okay? It's not replacing your database. It's not replacing your transactional systems. It completes it. It complements it. Because I'm recording something on my business network. Okay? Make sense? Well, the implementation that we're talking today about is Hyperledger. And Hyperledger is under the umbrella of the Linux Foundation, a project of a blockchain implementation. So Hyperledger is a blockchain for business under the Linux Foundation organization. You see the links here. Now, being one project, it has sub-projects, it has tool sets, so there are different components that we're talking about. It's a collaborative effort. There's no one company owning it. It's an open source product or project, open source project, using open standards, open governance model. More than 180 members are available, are doing that today, or are contributing to this project. So therefore, it's not about having a small number of companies having an idea how to implement it. It's a very huge number, and it's growing constantly. And that's what we see in the projects, that's what we see in the interest, and that's why with these different, or with this high number of companies, you can imagine that every company has some needs where you have to implement that into that blockchain technology. That means it becomes more and more, or broader. You don't need to use all the whistles that are there, but it becomes from a technology perspective and from a scope perspective broader than it was at the beginning. Now, with version 1.0, since July 2017, that's almost a year and something, we have that version that companies are now using to go productive, to do that and build up their blockchains with that version of the so-called Hyperledger Fabric. And we will see the relation, what is now Hyperledger and what is the Fabric. As you can imagine, Fabric sounds like fundamental, it's the runtime. And it has more functions than just running your blockchain, but it is basically the heart of the blockchain technology. And therefore, if you're looking at this page, you will see here the so-called greenhouse, how they call it now. Part of that are the frameworks, and one of the frameworks, they call it framework, is the Hyperledger Fabric. There is another Hyperledger Bureau, Indy, for identity, mobile application focus with Iroha, the Sawtooth, permission support. So there are different aspects that are covered in different sub-projects of the Hyperledger project itself. There are also tools available to make it easier to develop, maintain, and work with the Hyperledger, with a blockchain implemented by Hyperledger, okay? So with that said, just to have the terminology right now, Hyperledger is the project, Hyperledger Fabric, part of it, Hyperledger Composer is another project under that umbrella to build a such network much easier. And then we have Ibm Blockchain Platform. The Ibm Blockchain Platform is built around Hyperledger with components, services that you can take advantage of and then bring it in your in-house or work together with IBM to build your blockchain or a blockchain with different companies as well. So we're engaged in a couple bigger projects right now to build industrial-based blockchains so that insurances can participate, financial institutions can participate to those blockchains. And I'm based in Germany, working, and as you've heard, the GDPR that was enforced this year, it's not making many happy, many companies happy, because there are enforcements that are really hard to fulfill, or you have to be very careful how you work with data these days. It will be a process to get there, and I see that as a beginning, and the decision, for example, to say in a couple years, all the banks have to participate in that blockchain, in a banking blockchain, that I can imagine something like that, or insurances or stuff like that, that they have a trusted model to build business with each other. So when you're asking yourself, when do I need to think about blockchain? It's all about simplifying, and it's all about building trust in a business-to-business model without trusting each other and without having a man in the middle. If you do not have that, you don't need blockchain. Okay? So when we're looking at blockchain for business with Hyperledger now, it is about increasing that trust for asset transfer or trades. Again, no cryptocurrency mentioned, right? Now, if you think, well, if the questions comes up, yeah, but I'm doing business to business and I'm selling something. So there is some money involved, some financials are involved. It's not excluded, but it is not based on an implementation that uses cryptocurrency, okay? So important is, it is for anything that is capable of being owned, transferred, controlled to produce value. And that can be fundamental types of assets like tangible assets, like a house, like something you can touch, or intangible assets, mortgages, right? Or financials, intellectual, patents, digitals, like music rights, all that can be done and is a business case. Cash is also an asset, has a property and anonymity. So therefore, the Hyperledger implementation of blockchain is basically for everything, for businesses. The goals enable multiple different parties. And some examples here for finance, to streamline the settlement, improve liquidity, or increase transparency. Healthcare, increase the data flow and liquidity, or reduce cost, improve patient experience. Or supply chain, that's a very big one. Track parts and service provenance, ensure authenticity of goods, all that. And there are examples for that already in production. A very prominent one is Walmart, from pork to fork. It's implemented in China. From pork to fork means every shop can see where the animal is coming from and what was the way, its way to get to what it is today, you know, to the steak, to the whatever. So from pork to fork. Interesting, but it's a helpful implementation. Now let's get to the technology a little bit more deeper. So we have the participants in the blockchain network. They are called peers. Okay? The peers are all running something called blockchain fabric, which is having these security and crypto services across all the services that are implemented. So from the first beginning, the implementation is securing the data everywhere. So from entry to storing on disk, everything is encrypted and secured. Membership services. How do I become a member? How do I leave? Consensus service. I can only apply if I agree with the consensus of the chain. Chain code services. These are the conditions when I can execute or I can record a transaction on the blockchain. And the ledger services, the update that the ledger is updated based on the chain code, the consensus, and the chain code services around. Okay? Now let's do a little more deep dives here. Again, the security and crypto services overall, identity, so the membership services are dealing with the membership and enrollment, identity. The ledger and the transactions are dealing with the consensus service, ordering service, the distributed ledger, and the network protocol. As you can imagine, that is also part of the consensus. What is the network protocol? What is the cipher suite for encrypting and making the transaction secure, the communication secure, and how to communicate with the distributed ledger. And then the chain code or the smart contracts running in secure environments that I cannot change them, because that's the area where it's very sensible, that I do not change a condition so that I can use that around the normal rule, around the consensus. Okay? The actors, the functional actors in such blockchain solutions now are from the blockchain architect, blockchain developer that creates the chain code applications, the blockchain network operator, but also the access to existing logic. Because we're not starting from scratch. We're recording something on our business network. So I have already applications, transactional systems. How do I interface with them? And that's another very important area when we're talking about these blockchain implementations. How do I interface with my existing system of record? And that's the next hour. So part 2 of this blockchain presentation is how to integrate with the options to integrate with system of record. Traditional data sources, membership services. So these are all actors in a blockchain solution that need to be available or active to do that. And with that said, when we're looking at the functional perspective, my application or user is using functionality to install or instantiate or invoke or query through my chain code the ledger, or write into the blockchain, or write blocks into the blockchain. As the notion is telling you, blockchain is a chain of blocks, and the blocks contain data that you want to preserve. It's like the logging. It's the data that I want to have stored somewhere. And because of the format here, it is prefixed or it's enhanced with a so-called state database where I can query. My queries are going against the state database to see what happened. So that's basically an index of the blocks and of the chain. Okay? The functional components are the peers. They are the participants. I have to be a peer to act on that blockchain. The channels, that's another notion. I am acting on a channel. When I'm making business with a certain other peer, that's one channel. I can have a total different channel if I'm doing business with my bank. Okay, so my partner or my company can be on a total different chain code with the suppliers than it is with the bank. So that's why, again, we don't have a blockchain that covers. We don't necessarily have a blockchain that covers everything. We have dedicated different channels that are used for businesses in that network. We have a certificate authority or certificate authorities, multiples, which provide identity services to the participant, to the peers. The chain code, which enables and gives us the possibility to define conditions. The consensus and the ordering service that will bring together the verification of the transaction and will then write to the ledger. And we will see that logic in a minute. So when we're talking about peers, everybody in the blockchain is a peer. There are two different peers that we have. It's an endorser and a committer. Okay? So the peer is one of the nodes. And any number of peers may participate in the network, but everybody is known that participates. It's not anonymous. That's why I need to convey to that consensus. A peer can be an endorser or committer, where the condition or the endorser is always a committer. And we'll see what they can do. So the endorser executes and endorses transactions. The committer just verifies and validates. With that said, when we're looking at the shared ledger, we're having here the chain of the blocks. We're having the state database, a key history index, and the block index. So that's basically the structure that is defined as the shared ledger. Now, the top of it, here the state database, that's replaceable. CouchDB, for example, has a database which is an external option right now. So that we will see that's an option, which database you want to use. It is when we're doing projects with customers together, we decide for a certain format with a certain database that is used there. When we're looking now that the shared ledger is using or is containing the last written key or value, and the block index contains all the blocks. That's my other database. I can see the difference, what is stored and what can I query to not interfere in terms of when I'm storing into that database, the queries are going against my state database. These blocks now have to be tamper-proof. So I'm not allowed, or nobody can change the chain or can change something in the middle. And that's built basically by how the blocks by themselves are built. First of all, the blocks, such block in the blockchain contains the data to be stored in the blockchain, the hash of the data and the hash of the previous block. So far, so good. So basically, fingerprint, right? The first block has a previous hash of 0. There's nothing before it. And then it has the hash, its own hash. The next block I'm inserting into the chain has the hash from the previous block and its own hash. And then I'm inserting again the previous hash and its own hash. So what happens now if I try to change something in the middle? If I change something in the middle, the hash will change. So that's compromised. The chain is compromised. And that's how we can make sure that you cannot change something in the middle, because if that happens, my chain is broken. Okay? And that's how it is ensured the chain is always, the single truth that is there, and you cannot change it. Of course it is protected, of course it is secured and encrypted, but with this, even it is the possibility to ensure that the chain is integer. When we're talking about channels now, any questions so far? Yes?
So you talked about how blockchain is trusted and creates a trusted environment by eliminating the need for middlemen because of the consensus model. And you also talked about private blockchains where we still have certain parties maintaining the consensus model. So you sort of have a central authority still there trying to regulate the rules and let's say chain code in that system. So how can that be a truly trusted model versus a public blockchain?
Okay. Very good question. So the question is, because I have a consensus, somebody has to maintain the consensus. And that's not the case. The consensus is not maintained by one entity. The consensus is maintained by the members, by the peers. All the peers have to agree, or you have a certain consensus model. Even the transactions are verified. You cannot do a transaction by your own. The consensus model could be 50% of the peers have to agree that this transaction happens. So therefore, the trust model is not based on a single entity. It is based on the participation of the peers or the feedback of the peers related to consensus, related to transactions. But I'm coming to that point as well, where you see when I'm initiating the transaction what happens. But now, based on the consensus, the consensus is basically the first step when a blockchain forms. Can we agree to store this data? Can we agree to use that network protocol, crypto cipher suite? That is part, and that is a consensus between all the peers, not one. Okay? And that's a difference, because nobody can say, well, now we change everything, because it's not, they cannot. And even if you want to participate in a blockchain, there is part of the consensus, how many peers have to agree that you participate. There might be cases where you say no. Bad, whatever. Yes?
You agreed on a given cipher suite. The cipher suite will become obsolete. So what do you do in that case? Your peers vote?
Yes. So one entity cannot change anything in the chain. It is always a kind of voting mechanism. It's a consensus mechanism, and there are different ways of enforcing those consensus mechanisms. Well, now let's assume there are 3 parties in that blockchain. Then it's much easier to make some changes than if you have 20. Okay? So if you do it in your own company, for example, then the company itself can decide from now on we want to have a change in terms of even something like that. Our blog is too small. We want to enhance that. We want to have a bigger blog. And that's a consensus you can decide or you can propose. And then the consensus has to, or through the consensus, the peers have to agree, and then it's valid.
And along those lines, so let's take Hyperledger, for example.
Yes.
And you mentioned IBM is a premium member in Hyperledger, right? So would IBM have a higher say, or would every peer in that consortium have the equal say? Okay.
IBM is one member as anybody else. They don't have a higher say. So there is no, well, the premium members are premium because they invest more into the development of that blockchain technology. But it's not, they don't have more to say because that's a consensus. But now think of IBM is part of the development of the technology. When we're talking about the blockchain implementation, it would be, for example, I give you at the end, the consortium that we work right now with about 15 insurance companies. IBM has no say at all. We're helping to develop that blockchain, but the insurers, they know what they want to have in a block. They know how they want to proceed, what is the condition that they make business with each other, these chain codes, and we're coming to that as well. So they decide that. IBM is just helping to implement it. In the open source community, IBM is a premium member. That's correct. But that's just developing the technology called blockchain or Hyperledger implementation. Okay? Make sense? Okay. So channel, I said the mechanism to control the transaction visibility. So between the peers, I'm acting on a channel. I'm not acting on the chain. That was at the beginning. After version 1, so we had a version 0.6. That was before July last year. There was the chain always, it went around through the chain. Now you're acting on channels. So I can have special channels with the actors or with the peers I'm doing business with in the same blockchain. And we'll see that. And then we have the orderer service. The order that is the model basically where it accepts the transactions, delivers the blocks, and it manages the pluggable trust model. Now what we see here is another very high characteristic because you have models that you can have as a base. Like, for example, the crash fault tolerant or Byzantine fault tolerant mechanism that is as a base there, so nobody can change. That's a model that is used underneath it, and everybody is forced to that from an order perspective. The membership service, in the membership service, we can have a fabric certificate authority, or we can have an external certificate authority, or we can have both that are then where the membership service provider is using to generate your certificates or to generate certificates based on a master certificate. So these kind of things that are, again, in the consensus, everybody agrees that's how we do it. That's what we're using, external certificate authority, or based on one certificate here, we're using our fabric certificate authority. Okay? And here you see the fabric certificate authority. That's a special component as well, where it is the default implementation for the membership service provider. What I want to point out is we have the possibility here to use so-called hardware security models, which is an implementation that can use our Z crypto cards now. And when we're using those, we know exactly how fast and how secure we can work with those. So the hardware security model versus the software or versus an LDAP authentication ID is the hardware implementation. So that's a decision again on the consensus. What do we use and how we use it? Okay, so again now, consensus service, the process by which the agreement is obtained, transaction endorsement, ordering, and validation. The endorsement is that each stakeholder decides whether to accept or reject the transaction. So the endorser, I'm proposing a transaction. Endorsers are defined in the blockchain, and they decide yes or no. The ordering sorts all transactions within a period into a block, and the validation verifies it and certifies that it satisfies the policy. So again, here the consensus plugin can be used with specific configurations, like the PBFT consensus plugin. That is part of the fabric. So that as a default, you can change that. Okay, now here is a picture of the blockchain solution with the distributed shared ledger. With the distributed shared ledger is with the fabric. So the blockchain fabric is running in every single peer. And then I have channels. And you see here, based on the colors as well, my logistic peer is having a channel to my commercial peer. My bank has a channel with the auditor and a commercial peer, and we have two channels between a real estate administration peer. So the administration peer has a channel with the real estate and one with the bank. And I'm always acting as a peer on a channel. So I can act as an city administration peer on the channel to a real estate and on the channel to the bank. I cannot act with a commercial institution because I don't have a channel defined for it. Although all of these peers belong to the same blockchain, okay? I'm acting on a channel. Belonging to the same blockchain means consensus and the privacies that the entire blockchain decides, all the peers. Okay, yes?
Just a question on that previous part. So I get the network, I get the channel. Now, when you say peers, each one of those entities is a peer. I'm confused there because what I've seen so far is that each of those entities is an organization, and within the organization, you have peers that can either act as committers or endorsers or whatever. So the peers are like processes that run the chain code within that organization. Am I correct, or is the chart wrong when you call them peers?
A peer is an actor on the blockchain. And that actor is an entity, and you might have in your company 5 actors, or you might have 1. Because you might have a main department that is taking care of financials, another division that takes care about the partners, the partner network or the suppliers. And they can be part on the same blockchain, but they are different peers as entities on the blockchain, or can be different peers. Okay? Make sense? So a peer is an actor on that blockchain. It's not necessarily an institution. I represented it as an institution because I talked about business-to-business relation between the institutions. If you're drilling down now, you can have one institution having all these peers can be in one single company. So it depends on who do I act with. Are they part of that blockchain, or are they part on another blockchain?
We can tell.
Okay. So how do I build a blockchain now? First of all, my Hyperledger fabric, and I take the ordering service and start the network peers. And now I have a couple of peers here as an example. Endorsing peers, and P4 is a committing peer. Okay? After that, I'm building or I'm deploying the chain code, the conditions that this peer is acting, it needs to act. Okay? The chain code and the endorsement policy to be able to endorse a transaction. Then I'm defining the channels on the ordering service, and then I associate the peers to the channels. And now I know that this peer can act on 2 channels. All of them can act on 2 channels in that case. The consensus takes place within a channel by members of the channel. So I'm acting on the channel, not necessarily not on the entire blockchain. It's the channel which is the entity I work with. I'm part of I'm part of the blockchain, and I'm acting on the channel. Okay? So the peers finally instantiate that chain code on the channel. Which chain code is for which channel? I can have different chain codes for different channels. I can have the same chain code for different channels. So the flexibility is there. On the channels they need to transact. And the endorsement policy is specified at instantiation time. And then, that's how it works. I have a user or an application. that initiates a transaction on the red channel. The endorsing peers verify that transaction, and that means the transaction proposal is well formed, it has not been submitted already, so the replay attack protection is part of it. The signature is valid, the submitter, the client A, is properly authorized to do that operation on that channel, so that's all the verification, and that's done by the endorsement peers. The decision who is an endorsement peer is done in the consensus model of the design of the chain, of the blockchain implementation. Number 3, the proposal responses are verified. So here, I'm verifying, and the endorser are responding. So if the chain code only queries the ledger, if I just want to see what happened, that's easy, because the application would inspect the query response, and that's it. If the client application intends to submit the transaction to the ordering service, so I want to put something in the blockchain, I want to write something in the blockchain, update the ledger, the application determines the specified endorsement policies if they are fulfilled or not. And if they are fulfilled, it assembles the endorsements into a transaction. It broadcasts the transaction proposal within a transaction message to the ordering service, and then it will contain the data, the block, that then the endorsing peer with the endorsing peer signatures and the channel ID. And then the transaction is validated and committed. They are delivered to all peers so that everybody updates the ledger, the shared ledger, and then the ledger is updated. So these are the steps that are the process by initiating a transaction on the blockchain on a certain channel. Okay? And I have put in here the HTML page because that's a summary that you can read about a couple of pages of more details about those. So the fabric integration, the hybrid fabric integration basically is an application or my client, I'm a client, I want to initiate a transaction through either an mobile app, through a local application, through my system of record, can be my CICS that initiates something. I have membership services, I have the peers, the ledger, chain code, and I have so-called events. We did not talk about events yet. So the events are there that I can interface with the blockchain fabric. I can interface with blockchain based on an event, and that event can be in my system of record, or it can be in the fabric itself, so that comes back to me. Now, if I want to define, I want to create such blockchain implementation, and I have my business application here, let's say my CICS, and I have my Hyperledger fabric, how do I bring those together? And that's where one of the tools, sub-projects of Hyperledger, called Hyperledger Composer comes into the game. So the Hyperledger Composer gives you the possibility to create the link between your business application and the Hyperledger fabric, and even define and create chain codes. So the Hyperledger Composer set of tools for building the APIs, typically REST APIs. It provides typically the Hyperledger fabric provides a low-level interface, so that's why the Composer gives you the possibility to make it easier and faster with the definition of those interfaces of those APIs. You can very easily model your business network, test and expose those APIs, and therefore it is a help, is a tool set that helps a lot. Therefore, I would encourage, if you start, look at it. Another possibility is you can use the Composer online without even installing it. So try it online, and that's the link for it. Or you can install it, and these components are all free of charge. You don't need a credit card. You can just install them. The Hyperledger Explorer, that's another helpful tool, not to define, but to visualize what did happen on the chain. I can inspect what I can see, the transactions I had. So that's all possible with a Hyperledger Explorer. That's another tool that is under the umbrella of the Hyperledger. And here a couple of screenshots with the peers, how many channels, the chain code, which one, and then you see how they are related. And on the next chart, you see, previous and the data hash, the actual data hash, and the previous data hash of the transaction that belong to me, because I'm allowed to see where I act on which channel I act, right? So that's a nice way how you can interact with blockchain and the ledger. Now, the offerings that IBM has in this space are two. You see three here. The one is a starter offering for developers. The other one is the secure service container offering in the IBM Cloud today. So in the IBM Cloud, we have servers, Z servers. And if you're working with us to build a blockchain, you will implement that in a secure service container, which is a highly secured LPAR type that is securing to external more than a normal LPAR type, with the additional crypto features that you store all the data encrypted, that the network is encrypted, and that the code of the blockchain fabric cannot be touched. Nobody can get to it. You install that, and the installation is a secure process already to install that with a secure installer, and then you can just use the APIs. You cannot get to the code, so nobody can change it. Tamper-proof. Okay? And the last one is basically the self-managed on-premise implementation that you go to the website and download it. Download the Hyperledger Fabric, generally available, and install. That's a Docker environment, so there are Docker containers that you can install and play around with it. Okay? So with that said, we have this shared ledger, and the peers around it are using that shared ledger, and everybody has a copy of it. Now what you see, and based on your comment before, we have an auditor here. That can be a peer of type auditor in terms of as an auditor function, not as type, as auditor function, but every peer in the chain has to have the consensus if the auditor needs some information that they agree that he or this entity can look at special information. They cannot change anything. The auditor just there if there are anomalies that something needs to be clarified. And I cannot see the transaction of the other peers, but the auditor might be able to see and clarify those situations. So that's an entity to query, again, with a consensus of number of peers in the chain that they should and can do it. So it's not a decision like, I'm the boss, and whenever I want, I do an auditing. Okay? Yeah, so as an example now, B3I is one of the insurance industrial initiatives, and you see here the insurances which are participating, the major insurances. There are a couple of smaller insurances that are participating as well, and typically, or you don't see any US insurances here. That's an initiative that started last year. IBM is engaged in this project, and what they want to create is a kind of building blocks and a kind of insurance blockchain that they can invite others to participate in such blockchains, or insurances in US, for example, if they have special needs or special enhancements, they can take that as a base and enhance it. Okay? That's number one. Number two, a universal blockchain payment solution was announced from IBM as a service. So that's another trend where you see that we are going into the direction of what is my idea to implement a blockchain? No, it's more industrial based because it makes sense in a business-to-business context. The blockchain platform, IBM Blockchain Platform, that's where you can see what happens, what was done, which customers are using what, so examples, details tutorials, help from IBM, where you can request that. And I would tell you to use the IBM Blockchain Handbook, which is in edition 2 now, which is explaining very well, you know, the concepts behind the Hyperledger blockchain implementation. With that said, questions?
Because we share. Because we share.